Hi, I'm Jeff Morrow with Sierra Analytics, and I'm here with another featured feature for HDExaminer. Today's featured feature is the calculation speed controls. We're going to go over what they are and what they do. So what are the calculation speed controls? Well, if you go under Tools, Options, and you select Speed, you'll see these three options at the top: Fast, Medium, and Complete. These control what HDExaminer does when it's looking for a peptide. So, what's the difference? Well, let's start with fast. So here's an example. This one right here. You can see that we have the peptide that we're looking for, and right next to it and overlapping it is this other thing. So those calculation speed settings are going to determine how good a job HDExaminer does at getting rid of this interfering peak. The fast setting, which we've got set to now, is very fast and very simple. What it does is it takes a small retention time window around the expected retention time, in this case 6.35, and it just sums those spectra and looks for the peptide in the resulting spectrum, and that's it. So I'm going to actually recalculate this result to show you what fast does. You can see it was pretty quick there. But there's still this, big interfering peak because all the software did is it took a window around the expected retention time, summed it up, and called it good. So this interfering cluster is actually taller than the cluster that we care about here. So that's okay, but not what we want. Now, here's the thing. If you've got a peptide that doesn't overlap, then chances are the fast algorithm will actually work just fine for you. The extra calculation that HDExaminer does is mostly to try and improve your result in cases like this. If there's nothing nearby interfering, then the fast algorithm will work just fine. So use the fast algorithm when you don't think you have a lot of overlapping peptides, or if you just want to do a quick and dirty calculation to look for one or two peptides in a bigger run. So let's move on now to medium. In the case of medium, what it does is it first does the fast algorithm. It sums up a range of spectra around the expected retention time, and it tries to find the peptide. What the medium algorithm will then do is it will look in the extracted ion chromatogram for a clear peak, and we actually have a clear peak here. The medium algorithm will move your retention time range to just use that clear peak that it finds, and it repeats the calculation. So now that we've got it set to medium, I'm going to recalculate. It's going to think for a second, and now you can see two things. First of all, we have a nice tight range. The retention time range is just using the peak in the extracted ion chromatogram, and as a result, the peptide that we care about is really strong and really clean, and this interfering thing is actually pretty low. It's only at a intensity around 20,000 or so. So that's pretty good. And in a number of cases, the medium calculation will do enough. But every once in a while, you'll get some tough nut to crack that requires more. And in that case, you should use the complete algorithm. Now, I'm going to show you here that for this particular result, the complete algorithm actually does a little bit better job. So the fast algorithm, as I say, just takes a single retention time range, sums it up, finds the peptide, and that's it. The medium calculation will then find a peak in the extracted ion chromatogram, sum that up, and redo the calculation. What the complete algorithm does is after it finishes that, it will then start fiddling around with the retention time range. It will move it left, right, it will compress it a little, it will expand it a little, all in the search for a better result. So let me show you what happens here with that. I'm going to go to speed, complete this time, and now recalculate the result again. Now, of course, this version takes longer because it's doing a lot more, but it's still, relatively quick there. And now if we zoom in, we can see that it's actually compressed the retention time range a bit. It's not actually using the entire peak anymore. It's using only part of it. And as a result, this interfering cluster that's been our nemesis through this whole situation is now really small. It's now closer to 10,000 intensity. So we've increased our signal to noise greatly by using the complete algorithm. And that's what it's there to do, is to do a bunch of extra calculations and find a better result in these really thorny cases where there's something interfering that we have to get rid of. So to recap, the fast algorithm takes a retention time range around the expected retention time, sums it up, and just uses that data, whether it finds anything or not. The medium algorithm does the fast algorithm, and then it looks for a clear peak in the extracted ion chromatogram. If it finds one, it changes the retention time range to that peak and calculates again. The complete algorithm does the medium algorithm, and then actually starts fiddling with the retention time range to get the best result that it possibly can. If you have any questions, feel free to contact us at support@HDExaminer.com. And once again, I am Jeff Morrow with Sierra Analytics. Thanks for watching.